So what we've done so far is all I've given you is a coordinate. You plotted the coordinate and then gave me the three trig ratios, correct? So the coordinate was always an x and a y. It was always an x and a y. We could just use tan, positive, and we get a reference angle, we could draw our standard position. We were always given x and y, and we always had to solve for r. Agree? That was the coordinates. Now what they can give us is they can also just give us a trig ratio, which still gives us two things, but it might not be x and y. The only way it is x and y is if they give us a trig ratio of tan. If they give us tan, they could just give us tan, or they could give us a coordinate. It's the same thing, right? But if they give us cos or they give us sine, they're giving us x and r or y and r, and we have to solve for the other side. Okay? So let's look and see what they gave us here. Suppose theta is an angle in standard position with the terminal arm in quadrant 4. So we know we're sitting here between 270 and 360. And tan theta equals negative 1/5. Tan theta equals negative 1/5. So once again, they gave me x and y, just like as if it was a coordinate. You have to watch yourselves, guys, though. Because remember that negative sign when it's a fraction can be in the top or it can be in the bottom, correct? So just because they have it in the top doesn't mean it's necessarily in the top. Okay? What is tan as an acronym? Tan your x box. So it's y over x. We agree? Now, it needs, you have these notes somewhere. You do. I gave them to you like a week ago.
A week ago?
Yeah, just go searching. All right. Humana. Okay. Yeah. Okay. So, he's a rebel without a cause. So here we are. So we can have tan theta equals negative 1/5, or paying attention, we could say it's tan theta equals 1 over negative 5, correct? This would be y, this would be x. It can be either or. So that's why they have to specify what quadrant it is in. That's why they have to specify what quadrant it is in. Because if I draw 1 and negative 5 as the bottom one, if I draw that as my y and my x, 1 and negative 5 for x and y, that would be this coordinate. That would be negative 5, 1, which would be in quadrant 2, correct? So it's not this version of it. It actually is the original. But you have to remember that they can move it, right? So they could have given it to me as 1 over negative 5. It has to be this one because it's 5 and negative 1. 1, 2, 3, 4, 5 and negative 1 falls in quadrant 4, which is where I need it to be. If I drew 1 and negative 5, or negative 5 and 1, it would be here, which is quadrant 2, so it can't be that version. Do you see how it could be in two places? That's where they have to specify what quadrant. So, we draw through that, pretending that's a straight line. See, this is my problem area. It doesn't draw straight. And then here, and we're trying to get this. And then we'll do the trig ratios. How can we get that angle in standard position? I'm going to draw 0, 90, 180 degrees, 270, 360. What do I need to find first in order to get the standard position angle? The reference angle, correct? And the reference angle is always of the what? Positive trig ratio. Remember, even if the trig ratio is negative, we don't care. If we're doing the reference angle, we are going to do tan theta, we'll do first, equals 1/5. I don't care that it's negative, I don't use negative. And then I go tan neg 1. And I get theta equals tan neg 1 of 1/5. So when I do the reference angle, I always do of the positive. When you do tan neg 1 of 1/5, what do you get?
11.3.
Does that seem realistic that this might be 11.3? It's pretty tiny, right? So I'll just use 11 degrees for now. Okay, that's the reference angle. How do I get the angle in standard position?
Minus 360.
Yeah, so I go 360 and then I take off the 11. Take the 360 it the whole way. So I'm going to go standard position equals 360 degrees minus 11 degrees, and we get 349 degrees. So this angle here is 349 degrees. So that's how I get the standard position angle every single time. I find my reference angle, draw it, and figure out how the heck I get my standard position from there. Okay? To get the three trig ratios, I'm given one. I need two others, correct? I'm given tan. The other one I was given a coordinate, and then I had to get tan, sine, and cos. This one I'm going to be given a trig ratio, and then I have to get the other two. Okay? So I know tan. I need sine theta, sine your resume, and I need cos theta, which is cook extra rice, which is great. I have y and I have x. What do I still need? R. How do I find R? Pythagorean theorem. So I'm going to do r squared equals x squared plus y squared. And then I'm going to get r squared equals 5 squared plus negative 1 squared. So r squared equals 26. Square root. When I take the square root, I have to put what in front of it? Positive and negative. Does root 26 break down into anything?
No.
Nope. So it's just going to stay root 26. The square root of 26. So when I go to do my trig ratios, I'm going to have y over r. So sine theta equals y, which is negative 1, because I labeled it, over r, which is root 26. Can I just leave it like this? No, I need to rationalize my denominator, which means I need to get rid of the radical. And how do I get rid of a root 26? Times by root 26, because root 26 times root 26 is just 26. And then there's nothing I can take out of 1 and 26, so I'm done. That is sine theta. Then I have to do cos theta. Cook extra rice. So my x is going to be, it's labeled over here, it's going to be 5 over root 26. How do I rationalize root 26? Multiply by root 26. So I'm going to get 5 root 26, and then root 26 times root 26 is just 26. Is there anything I can take out of the 5 and the 26? Anything I can take out of there? No, so it's done. So my standard position angle is 349 degrees, and my two other trig ratios are sine theta, which is negative 1 root 26 over 26, and cos theta, which equals 5 root 26 over 26. I'm not going to make you try this one. We're going to go do it together first. So what's the difference with this one? I gave you cos. We agree? Our first thing we're going to have to do is label it, because we don't know if they gave us y, x, or r. Right? They'll always give us 2, and we'll be missing 1. Okay. So we need cos theta equals negative 3 over 4. And cos is what? Cook extra rice. Now I know it's labeled correctly. Why do I know that the sign is correct? What can't r ever be? Negative. So I know that if they have r as negative, I need to take the sign on the bottom and move it up. Correct? Okay. So they gave us x and r. Really hard to draw x and r. If I have x and y, it's really easy to sketch. Correct? X and r is hard. So how the heck do I get y? Pythagorean theorem. I'm going to rearrange it. So Pythagorean theorem is r squared equals x squared plus y squared. And I need y, so I'm going to subtract the x squared, right? So I'm going to get y squared equals r squared minus x squared. So whenever you don't know the radius, or sorry, whenever you don't know one of the sides, you just take the radius squared minus the other side, right? Because that's all you do with Pythagorean theorem. It's hypotenuse minus the other side. That's what you did in Trig in grade 10. So we're going to go y squared equals 4 squared minus negative 3 squared. Remember, when you minus a negative, when you square a negative, it will always turn positive. So we're going to get y squared equals 16 minus 9, which is 7. We agree? When I took the square root of an r, it always was positive. I told you it's radius. Radius is a length of measure. Lengths of measures have to be positive. We didn't have an option. But x's and y's can be negative or positive. They just be in different quadrants, correct? So when I take the square root of this, I'm going to get plus or minus 7. So I'm going to have y equals plus or minus root 7. Can anyone tell me how I'm going to know if it's positive or negative? You have to, they have to give you a quadrant. If not, you could have two coordinates, right? If they don't give you a quadrant, we can have negative 3 in root 7, positive root 7, and negative 3 and negative root 7. So it could actually be in quadrant 2 or 3. It tells us it's between 180 and 270. What quadrant is that? That's, well, let's find out. 0, 90, 180, 270, 360. What quadrant is it in? 3. So what does my y have to be if I'm in quadrant 3? Positive or negative?
Negative.
Negative. If it's down here, it has to be negative. If they gave us between 90 and 180, we would say positive root 7, correct? The quadrant tells us. So it's in here. All my y's here are negative. We agree? So my y then is y equals negative root 7. So if I want, I can label them over here. I can say, okay, my x is negative 3. My y is negative root 7. My r is 4. I have all my pieces of information to do my trig ratios. I also have my information to be able to sketch it. It's at x equals negative 3. And what's root 7 as a decimal? Because I can't draw root 7. It's going to be 2.6. So I'm actually sketching my coordinate at negative 3 and negative 2.6. 1, 2, 3, negative 2.6. It's about here. I'm trying to find this. How can I find my standard position angle? I need to get my what first? My reference angle, correct? And how do I get my reference angle? I take the positive trig ratio they gave me. Even if it's negative, I take positive, correct? So, my reference angle comes from cos theta equals negative 3/4. But what am I going to use? Yeah, cos theta, I can just use cos still, but it's going to equal what? 3/4. I always use the positive. Have I ever not used the positive? No, I always use the positive. Now instead of tan neg 1, what I'm going to have to do? Oh my goodness, my speaking is not working. Yeah, cos neg 1. Could you have just taken the tan ratio if you really want to keep sticking with tan ratio? Sure. Cos neg 1 of 3/4. Everyone trying it out? You get 41. Does that seem realistically kind of at 41? Yeah, halfway is 45, so we're pretty close, right? If it's like 2 degrees, be suspicious. Either you drew it terribly or you're wrong, right? So we know that reference theta equals 41 degrees, which means this here is 41 because it's the bow tie angle. How do I get standard position in quadrant 3? Yeah, 180 get me there, and then another 41, right? I know people are like trying not draw. If you draw, you'll make way less mistakes because you can visualize it. Then we'll do our 2 trig ratios. We have cos, so we need sine. Sign your resume and tan your X box. So sign your resume. Sine and y is negative root 7 over 4. My denominator is rationalized. I don't have to do anything. You can have a radical in the numerator, just not in the denominator. And then tan your x box. Y is negative root 7, and x box, your x is negative 3. So they'll write it as root 7 over 3, because they'll negative divided by negative is positive. We're going to work on some together. So I'm going to get you to try this one. I want the two trig ratios that are not there. And angle 17. These are on a separate sheet of paper. These are going to be your homework. So we're just going to work on them together. Page 96. Number 8. So A is cos theta equals negative 2/3 quadrant 2. So I want the standard position angle and the two missing trig ratios. And then B, sine theta equals 3/5. Quadrant 1. Tried those two. We have to label it. So we're going to have cook extra rice. The x is in the right spot because, or sorry, the negative sign's in the right spot because r can't be negative. So we know x equals negative 2. We know r equals 3. We need y. Right? The quadrant will let us know if y is positive or negative. We agree? Before I even go to do this question, if I know it's quadrant 2, is y positive or negative in quadrant 2? It's positive. So I'm going to put a plus sign here so I don't mess that up. Because immediately if they give me the quadrant, I have the sign. Right? I'm going to solve for y. So I go y squared equals r squared minus x squared. Y squared equals 9 minus 4. So y squared equals 5. And then we get plus or minus root 5. But because it's in quadrant 2, we've already discussed this, y is going to be positive root 5. So I have my three pieces of information to do any trig ratio they ask me for, right? So if I want to do my trig ratios right away, I could. I can go tan your x box. So your is root 5. X box is negative 2. Now remembering, they could give the answer like this on the test. They could go negative root 5 over 2. Could they not? They could put the negative to the top, and it would still be the same thing, wouldn't it? Or they could put the negative in front. These are the same answer. And then we have sine. Sine your resume. Y is root 5. Resume is 3. Do I have to rationalize anything? Nope, because the radical's in the numerator. Now I do need to find my reference angle. I know it's quadrant 2. If I go to try and sketch this, what would my coordinate be? It would be negative 2 and root 5. Root 5 is 2 point something. So it's negative 2 and a little more than 2. So it's like here. So we have something going like, I'll use different color. We have this, and then this, and then this. So something like that, correct? We need to get the reference angle. How do we get the reference angle? We take the trig ratio they gave us, and we take the positive of it. Even if it's negative, we take the positive of it, right? Over and over and over. I keep explaining the same thing. So to get my reference angle, the trig ratio they gave me was cos theta equals negative 2 over 3. I'm going to say cos theta equals 2 over 3. Then how do I get cos theta by itself? Cos neg 1. So I get theta equals cos neg 1 of 2 divided by 3. And what does theta equal? What did you guys get? 48? Don't forget the degree symbol, or it's not degrees. Does that kind of seem realistic that that could be 48? From here to here? Seems like it to me. So if I want to help myself out, I'm going to label. How do I get the actual angle, though? How do I get this? Standard position angle. 180 minus 48. Which gets us 132. It's my standard position. For B, it's sign your resume. So this time I have Y and I have R, and I need to find. I have Y and I have R, and I need to find X. Sign your resume. So I have R equals 5, I have Y equals 3, I have X equals, I don't know. In quadrant 1, is X positive or negative? Positive. So I know it's going to be positive something, correct? How do I do it? I just do Pythagorean theorem like before. So I'm going to go that's a lie. I'm going to go X squared equals R squared minus Y squared. So X squared equals 25 minus 9. I want to give the answer. X squared equals 16. Square root, we get plus or minus. 16 is a perfect square. So it's going to be plus 4. And it's plus 4 because it's in quadrant 1. Now I have my 3 answers. I have an X, I have a Y, I have an R. I can find my other 2 trig ratios. I have sine, I need cos, and I need tan. Cos theta, cook extra rice. So in this case, cos theta is going to be 4 over 5. And then I need tan theta, tan your X box. I'm going to do tan theta equals Y, which is 3, over X, which is 4. Now that I have my X and my Y, I can sketch it, correct? My X and my Y are, my X is 4, my Y is 3. So 1, 2, 3, 4, 1, 2, 3, it's like here. Once I get my reference angle, what do I know? In quadrant 1. They're the same. Once I get my reference angle, I actually have my answer, correct? And how do I get my reference angle? Well, I just do whatever trig ratio they gave me positive. It has to just be positive anyways. So I'm going to go sine theta equals 3/5. And then how do I get rid of sine? Sine neg 1, or inverse sine. Theta equals sine neg 1 of 3/5. This is the reference angle. So what do we get for theta? Can you do 3/5? How much? 37. So my standard position angle is 37 as well. So quadrant 1 rocks. Okay, you guys have C, D, and E to do. Now, if you look at E, E is tan theta equals 1. What is 1 if it's in a fraction form? 1 over 1. That's it. So your X and your Y are the same. So you're doing C, D, and E for homework.